All right, guys, welcome back. This is the first of a few planned kind of interludes that cover a little bit more of a technical subject than the rest of our course offerings. So this first one is going to be about kind of computer hardware and what makes a computer. Now, what we're going to be talking about throughout most of this is using the example of a desktop, a big personal computer. But the same basic rules apply for everything from laptops to cell phones to tablets to whatever other kind of computer you want to talk about. They might look slightly different or be sized slightly differently, obviously, but all these kind of pieces of hardware exist in all of the different kinds of computers. Okay, so first, our funny internet picture of the section. See, that's funny. That's a good prank. Nobody gets hurt. Nobody gets embarrassed. That's funny. All right. Okay. So, first thing we got to talk about when talking about hardware is the case. Now, the case is usually very, very, very simple. It's just kind of a metal or plastic container for the other parts of the computer. The only really moving parts on these are usually fans, because computers generate a lot of heat, so we have to dissipate that heat somehow. Fans are the easiest way to do it, so cases can have anywhere from 1 or 2 all the way up to half a dozen or more of these case fans. And the faster your computer is, the hotter it's going to get, so the more we need to dissipate that heat. Okay, this is a fairly fancy case. As you can tell, it's got a bunch of LED lights around the fans and stuff, and it's all nice and fancy. But just these are essentially just metal and plastic containers for the rest of the parts that keep them protected. Okay. The power supply. Okay, this is the piece where you can't see it on this picture, but the actual power cord that goes into the wall will plug into the back of this this piece right here. Now, so this is usually attached inside the case on the back, either at the top of the back or the bottom of the back. On my computer, which I'm sitting right next to, it's at the bottom part of the back. But if you just look at the back of your desktop and you see the place where the power cord plugs in, that's the power supply. It's got its own fan usually. This one has a fan on the top. It probably also has a fan on the back. And then coming out the other side is just all these cords. And these connect to the different pieces inside the computer. So each piece usually needs its own dedicated power. So these pieces are designed to plug into those different things, right? Now you'll notice these different plugins are all different sizes and shapes. That's because of Murphy's Law. If things can go wrong, they will go wrong. So what they do is they make these plugs a certain shape so you can only plug it into the right thing. You can't accidentally plug a power supply that's meant for your motherboard into a hard drive or the other way around, right? Because they will only fit one way, all right? That's very, very important. But it makes putting computers together a lot easier, which is very, very nice. So diskette drives or disk drives, there are lots of these. These are 2 of the more common examples, although the 3.5-inch floppy drive is a lot less common today. Some people still use them. Sorry, allergies. Some people still use them. For instance, my father, who's an old school IBM guy, still has 3.25-inch or 3.5-inch floppy drives in all his computers. But then there's also like CD-ROM drives and DVD-ROM drives, which are still relatively common. But if you want to go way back, there's the 8.5-inch floppies, and there's all kinds of different things. But these basically, these from a computer cybercrime perspective, these aren't really important. It's the disks that go in them that are usually going to be important. Video card. Video cards today are essentially mini computers in themselves. They're really, really, really advanced. You can see this one has its own fan. Underneath it has its own processor and its own RAM, which we're going to talk about what those are here in a minute. But it's essentially its own mini computer, and all it does is calculate graphics. It just does graphic stuff. If you're using a computer just for word processing and web surfing, they will usually have video cards built into the motherboard that you can use. These fancier video cards are for either video gaming, or a lot of people use them to mine cryptocurrencies, which if you're in cybercrime, you need to know all about cryptocurrency. So these video cards will kind of mine those cryptocurrencies a lot more efficiently than a normal processor. So lots of people who want to mine these cryptocurrencies will buy, as many of these video cards as they can, put them all into a sequence together, and just set them to mining. But these are usually solely dedicated to just pumping out good graphics. So if you like to play video games, like I do, you need a good one of these. Now, the motherboard. This is a very, very, very important piece of any computer. First off, there are a lot of things that are built into the motherboard which are incredibly important, but it's also kind of the thing that all the other things plug into, right? It's kind of the central nervous system, if you will, of the computer. So it has its own Ethernet card, which is, if you see there, it's kind of hard to see in this picture, but that's where you plug in like a LAN cable. If you don't have wireless internet, actual internet cable goes in the Ethernet port. Almost all of them these days have built-in sound. So, way back in the day, you had to have a separate sound card, like you had a video card. Today, it's almost always built into the motherboard. A lot of them today have built-in video cards, although again, the video cards that are built into motherboards are not nearly as good as the standalone video cards. But if you're just using your computer for kind of non-graphics intensive stuff, they're usually plenty fine. This is also where you plug in your input-output devices. Mouse, keyboard, joystick, microphone, webcam, all that stuff gets kind of plugged directly into one of these. And then it also has what's called the BIOS. Now the BIOS stands for Basic Input-Output System, and we'll talk about that in a little bit when we talk about boot sequence. But it's essentially the first thing, the first data, the first software, if you will, that turns on when your computer turns on. It has the most basic part of, okay, when you turn your computer on, it says, okay, I'm a computer. Okay, here's my motherboard. I can connect. Oh, look, there's a mouse and there's a keyboard, and I can make those work. And now, oh, I need to find a hard disk for an operating system, which we'll talk about in a minute. And it's kind of the most basic. Just how do I work? What am I? What hardware do I have attached? Kind of piece on the motherboard. Okay. And if you don't have one, you can't boot up your computer. Anything else to say about motherboards? We'll come back if I forget something. So, the processor. The processor is an incredibly, incredibly important part of your computer. It's the thing that does all the math, because that's all computers are, really. They're just math machines, right? Now, take in numbers, add, subtract, multiply, divide, and spit out numbers. This is the thing that does all the actual, or most of the actual thinking in a computer. If you want to make your computer run faster, this is usually the piece that you need to upgrade. This is what they actually look like. This is a modern Intel processor. You'll notice on the bottom, it just has these contact points. On the old processors, back in my day, they actually had little spikes that came out. And those were really, really, really sensitive. And if you accidentally, if you took your processor off your motherboard for some reason, and one of those spikes got bent, you were basically screwed and had to buy a new processor. So it's much, much, much easier to handle these things now that they have just these contact pads instead of the pins. But I still don't remember actually messing with one of these because they are very expensive. Just this piece is at least a few $100s. And if you mess it up or break it or shock it with static electricity or something, you're going to have to buy a new one, and that's a few $100 at least. But if you look at your motherboard, these will plug in onto a slot, usually looks like this, right here. But if you look inside your computer right now, you probably won't see this because it's got a heat sink on top of it. This heat sink is just a piece of metal because this is what creates a lot of the heat inside a computer, right? So this thing's pumping along, creating heat, and that heat has to go somewhere. So this heat sink is designed so that all the heat, it touches on the top. So the bottom of this touches the top of this. And all the heat that this creates gets kind of sucked into this metal piece, and it's got these thin veins, and that allows it to radiate heat out very quickly and efficiently. And then they usually have a fan on top to blow that air away. So it's constantly got cool air on this metal part, and it radiates that heat out very efficiently and very quickly. Sorry, allergies. So this is the thing that does all the math. Where does it get the numbers that it does the math with? RAM. RAM stands for Random Access Memory. This stores all of the kind of the ones and zeros and the numbers that the processor does the math with. This is where those numbers are stored before the math happens and after the math happens. Okay? This is what they usually look like. These longer ones is RAM designed for different kinds of desktops. A shorter one, that's laptop RAM. With laptops, they have to make everything physically smaller. So laptop RAM is physically smaller than RAM in desktops, right? So this stuff plugs in right here on the motherboard. You see these 4 slots? That means you can have 4 sticks of RAM on this motherboard, okay? And it all plugs in right there. So we've got our RAM plugged in here, our processor plugged in here, our video card plugs into one of these long ones here. The power plugs in here, right? This is where this is sticking out the back of the computer. So when you look at the back of your computer, you can see here's the sound stuff that you plug in, and Ethernet and USB and all these other things are the plugs that are available out the back of your computer. But yeah, RAM kind of stores ones and zeros before and after the processor uses them. So, what makes it complicated is that there's lots of different kinds of each of these. Once you get all of these parts, you can put a computer together very, very easily. It's like plug and play. Things only fit where they're supposed to go. If they don't fit, they're not supposed to go there. The one hard part about designing and building your own computer from parts you've bought from multiple different places is that you have to make sure each piece is compatible with the others. So if you buy a hard drive that's expecting one kind of RAM, but you buy RAM that's a different kind, it's not going to fit unless they're not going to work together. This gets real complicated real fast. This chart, as you can see here, shows a lot of the different, these are all different kinds of CPU sockets. Okay? So not all CPUs fit in the same socket. Not all motherboards have the same sockets. Not all CPUs fit in, so you have to make sure that you buy a motherboard with the right socket that fits the processor you also bought, right? And this is a very old one. This is probably at least 10 years out of date by now. But it hasn't gotten much simpler since this was made, okay? So there's a bunch of different kinds of RAM, and you have to make sure that the RAM type matches the motherboard type, and the processor type matches the socket type, and the video card matches the peripheral slot type, and all those things you have to make sure they match up. But once you've figured out how to do that, which it's a little bit simpler than this now, they've kind of standardized a lot of this, but once you've figured out which pieces belong in which slots and make sure that you get the right compatible pieces, putting a computer together is actually really, really, really simple and easy. So, a very, very, very simple computer, like way back in the day, 40s, 50s, 60s, computers only had the pieces we've talked about so far. They had RAM, which holds ones and zeros, and they had processors, which does math on ones and zeros. The problem is that RAM, because of the way it's designed, is volatile memory. Okay, that word volatile means easy to damage or easy to lose. With RAM, every time you turn your computer off, there's no longer power going to it, all the ones and zeros that were stored in RAM are gone. They no longer exist. You can't find them anywhere, right? So what would happen with these very early computers is you would turn it on and you'd have to type in every single 1 and 0 for all your programs, all your data, all your everything by hand. Then you'd run your program. It would, the processor would do the math and put the results into RAM. Then you could take the results out. But if you wanted to, you turn the computer off and all that information is gone. You want to do the exact same thing again, you got to start over from scratch. Turn the computer on, re-enter all the data, right? That was very clunky, and they started looking for ways to permanently store data. So when you turn the computer off, that data still stays there. When you turn the computer back on, it'll be like, oh, look, there's that data from the last time I was on. It's sitting right there. And they came up with a few different ways to do it. The easiest and most common way that we have in this day and age is the hard drive. Okay, there's a piece inside your computer that stores data permanently. When you turn the computer off, the data still stays there, right? So those old computers, it was just, ones and zeros go here, processor processes them, shoves them back in the RAM. Now, modern computers essentially look like this. Data goes from the hard drive into the RAM, right? That's part of the boot up sequence. When you turn your computer on, data goes from here to here. Now, when your computer's actually working, when it's doing stuff, when you're playing a video game or running a program or doing whatever, these two are talking back and forth very, very quickly, right? The processor's doing math, giving the results to the RAM. The RAM sends it to the video card if it needs to send it to that, or sends it to the, wherever. Does more math and talking back and forth and back and forth and back and forth and back and forth. Now, you may be asking yourself, why do we still need RAM? Why don't we just have the hard drive talk directly to the processor? And that is a very good question. The answer is the process of the hard drive talking to the processor would be way too slow. Okay? This process between RAM and processor is very, 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 very quick. If we didn't have this middleman, if we just had permanent data storage and that talking back and forth to the processor, our computers would be much, much, much slower than they are today. So because of speed concerns, we have our permanent data storage, we have our temporary data storage, or RAM, and we have our processor. And these two can talk back and forth very, very quickly in a way that these two couldn't. Okay? But this is essentially a very simple computer. You have your permanent data storage, your temporary data storage, and your processor. Does that make sense? All right. So next time, we're going to talk all about hard drives and permanent data storage. So join me for that.